All right, everybody, we're continuing chapter 3. We're going into 3.5 and 3.6. 3.5 is equations of lines. During lecture and class, there is a little bit of review, but I'm going to go right into the meat of the section. So the newest equation that we will use is point-slope form. So point-slope form is written y minus y1 equals m, which is slope, times x minus x1. You will be given x1 and y1 depending on the problem. Now we just need to plug it in. So when you're given the information, you need to know your slope and you need to know a point. In some cases, it will give you both the slope and a single point, so then you just plug it in. In this example, it asks us to write an equation into slope-intercept form and in standard form. But in order to get to both of those, you have to start with the point-slope form from the previous slide. So what we do is we take that information and we plug it in. And it will look like this. Sorry. We have our slope as a -2. We have x1, which is -11, y1, which is -12, and we plug it in. Y minus y1, -12, equals -2, because that's my slope, times x minus x1, which is a -11. From there, we just rearrange and solve until we get our information. So first we distribute that -2. We subtract 12 on both sides, and that puts us in slope-intercept form. So step number 3, after we subtract 12 on both sides, we get slope-intercept form. From there, we just need to add the 2x to the other side, and then we're in standard form, and our problem is done. Okay, so with point-slope form, it's just a matter of plugging in the information and solving. When you're writing with 2 points, so sometimes it doesn't give you the slope, it will just give you 2 points on the line. So step number 1 is to find the slope so we can put it in point-slope form. Remember, slope is rise over run, or change of y divided by change of x. And so we take the information we have and we're going to plug it in. When we plug it in, it will be -1 minus 0, 6 minus a -4. When we do our math and simplify, your slope becomes a -1/10. All right. From there, we can plug it in. So we can pick, I'm going to go back, you can pick any of the points. So you can do 6, -1, or -4, 0. But of course, we like to work with zeros because it makes our math easier. So in my equation, I'm going to plug it in. I have y minus 0, because that's my y1, equals a -1/10, which is the slope we just found, multiplied by x minus -4, because that's our x, and then we start to solve. So in order to clear the fraction, only when your numerator is a 1 can you multiply both sides by a 10. So you multiply by a 10 on both sides, you get 10y equals a -1 times x plus 4. Distribute that -1, move x, and then you have it in standard form, which is what we were asked to do. All right, so it's just learning to plug it in and then simplify it or rearrange it. If you have a vertical or horizontal line, the equations are very simple. Don't overthink this. So with a vertical line, vertical lines are always the x-axis is the same. So if your x-axis is the same, your equation will be x equals whatever it is, in this case, a -7. If you have a vertical line, okay, and in this case, it was asking what's the line parallel to y minus -3, and it passes through 10, 4. You put it in the information. So you know that y equals a -3 is a horizontal line. We're looking for a parallel line, which means it's also horizontal, which means our equation is going to be y equals whatever our y point is. In this case, y equals a +4. So our parallel line will be y equals 4. Functions, okay? Functions do not get tricky. Just do the basics. First, we need to know vocab. All right, so domain and range. Domain are always the x, range is always the y. So all of the x information, we're going to look at our set of ordered pairs and we're just pull down our x. We have a 4, -4, 2, and a 10. With our y's, you pull down the y. We have 2 9s, so I'm not going to repeat it. I'm just going to write 9 once. 3, -5. Okay, that's all. When it's asking for domain or range, you're just labeling what's there. Okay, when you have a function can have one x coordinate and one y coordinate. When you have a set of functions like the previous slide, you can have multiple y-x's that repeat, but your x coordinates have to be different. Okay, so for example, in this one, if you look and it's asking if it's a function, if you look at all the x's, so you have 4, -4, 2, and 10, they're all different, so it is a function. If any of those repeated, then it would be no. An easy way to know if it's a function or not is to use the vertical line test. So once you're given an equation and you plot that line, you use the vertical line test to determine whether or not it is a true function. If it works, you can put your vertical line anywhere on the graph, and as long as it only hits the line drawn, your vertical line makes it true. So my blue line, because it only hits the red line once, it is a function. Okay, so yay! It only hits it once, it's a function. In this case, you would draw your vertical line wherever you want. If you notice, it hits my circle twice, which means this equation, so if I was doing my math and I had this problem, it would not be a function because it would hit the vertical line twice. Function notation. When you see function notation, it will show as f parentheses x. Okay, it does not read f times x. It is function of x, and you will always be given. So in this case, if your f of x is 2, that means anytime you see an x, x will equal 2. So every time you see x, you replace it with the number 2. So in our example, we have f of x equals a -3x plus a 2. We replace it because we know x equals 2. So function of 2 equals a -3 times 2 plus 2. We do our math. We get -3 times 2 is a -6 plus 2 gives us a -4. So our function of x is -4. Okay, so our ordered pair then is x will be 2, and our function of x becomes our y. So function of x is -4. Our ordered pair is 2, -4. Here it is again, just a visual. So I know that my function is -3. I plug in -3 and do my math. My x is -3. My y is 15. Because x is independent, y is dependent on x. If you have any questions, message me, and we will see what I can do to help.